Hi there. In this video, we will go over Amazon Web Services Virtual Private Cloud components that help your virtual private cloud, your VPC, connect to the internet. In this video tutorial, we will cover specifically the VPC components that help your VPC connect to the internet. Overall, the various VPC components that are found in your virtual private cloud are your Internet Gateway, a NAT Gateway, Egress only Internet Gateway, a VPN gateway, direct connect gateway, VPC endpoints, peering connections, and transit gateways. Each component has a different purpose. These three components of your VPC help your AWS resources connect to the internet. An internet gateway basically allows your AWS resource to connect to the internet while also allowing the internet to connect to your AWS resources. NAT Gateway and Egress only Internet Gateway also allow connectivity to the internet but with restricted conditions. NAT Gateway is ideally suited for IPv4 address CIDR block ranges. It allows your AWS resources to connect to the internet. However, it restricts any unsolicited internet connection to your AWS resources. An Egress only Internet Gateway is meant for your IPv6 CIDR block range. At the same notion, it allows your AWS resources for your IPv6 CIDR block range to connect to the internet. However, it restricts unsolicited internet connection to your AWS resources. The other components of the VPC, such as the VPN gateway and direct connect gateway, help to connect your resources to your on-premises network. A VPN gateway helps you to connect your on-premises network using the internet as the rail connectivity. The direct connect gateway also allows you to connect to your on-premises network via a physical Ethernet connection which is provided by AWS and hence more secure. Your VPC endpoints basically allow you to connect to AWS services, and peering connection allows you to connect to other VPCs as well as the transit gateway. For the purpose of this tutorial, we will only focus upon components that help your resources connect to the internet. We help you visualize the various VPC components which were just described in the previous slide. So the components that help your virtual private cloud resources to connect to the internet are the Internet Gateway, a NAT Gateway which resides only within a public subnet, and an Egress only Internet Gateway. Other components of your VPC such as your VPN gateway, your virtual private gateway that connects to your AWS Direct Connect, your VPC peering connections, as well as the VPC endpoints. There are other components which provide different connectivity services but not related to connecting to the internet. Now let's go further into each of these individual components. Your Internet Gateway, simply put, is a VPC component that helps establish connectivity between your instances in your virtual private cloud and the internet. The Internet Gateway provides a target in your VPC route tables for internet routable traffic. In addition, it performs network address translation for instances that have been assigned a public IPv4 address. Internet Gateway supports both IPv4 and IPv6 addresses. One important exam point to note is there is only one Internet Gateway that can be added to a virtual private cloud. As shown in the visualization over here, your Internet Gateway is a highly available VPC component that spans across your availability zones. So you only need one Internet Gateway for all the resources across your various availability zones. It is a highly available component and it is managed completely by Amazon Web Services, and you do not need to worry about it having to fail or it being highly available. An elastic IP address is an important VPC component that helps ensures internet connectivity between your AWS resources and the internet. Its main purpose is to mask the failure of an instance in your account by rapidly remapping your static elastic IP address with a new instance so that your cloud service is agile. To help you understand this definition, we revisit our concepts of what an IP address does. An IP address is like a postal or a zip code for directions to a residential address. However, that address is for directions for internet traffic to reach instances in your AWS account. So IP addresses help direct your internet traffic to reach the correct instance in your AWS account. A static IP address is an IP address that, simply put, does not change. The opposite of this is a dynamic IP address. The reason static IP address is used is because it is ideal for DNS queries compared to a dynamic IP address, which, while cheaper to use, will affect the loading of your service for a client. However, static IP addresses suffer from a drawback that if the instance fails, then you need to redirect internet traffic to another working instance, which will have a different IP address. Elastic IP address resolves the shortcoming of a static IP address by rapidly remapping itself to another healthy instance for continuity of services. So you do not need to remap your new IP address of your new healthy instance to your AWS service. Elastic IP address does it itself. Please note, Elastic IP address support is only for IPv4 addresses currently. An important exam point that you should know is that your account is limited to 5 Elastic IP addresses. Now let's go over the other important VPC components, which are your NAT Gateway and Egress only Internet Gateway. As mentioned previously, a NAT Gateway is for IPv4 addresses and Egress only Internet Gateway is for IPv6 addresses only, and they serve a very specific purpose, which is to allow your resources to connect to the internet but do not allow unsolicited internet connectivity back to the resources. Now first we will explain what a NAT Gateway does. The NAT Gateway is a VPC component which you create within your public subnet. When EC2 instances in your private subnet need to connect to the internet, for example, they need to download some important patches, in that case what you do is you create a custom route table. The private subnet connects to this custom route table, which only allows traffic locally within your VPC. Your network access control list will direct the traffic from this private subnet to the NAT gateway in your public subnet. Your NAT gateway over here is in this public subnet, and an elastic IP address is attached to the NAT gateway. The NAT gateway will then route traffic from this public subnet, which has in its route table connectivity to the internet. So when an instance needs to connect to the internet, it goes from this subnet via the NACL to the NAT gateway. The NAT gateway routes it using the route table of this public subnet, which connects to the internet, and then the internet traffic connectivity is established. Once the patches are received, they are received via the internet gateway. They again come to the NAT gateway. The NAT gateway receives it, and then it does the network address translation, and it directs the internet traffic only to the specific EC2 instances in the private subnet. Any other internet connectivity to these AWS resources is immediately halted, because when it goes through your internet gateway, it must first go through your NAT gateway, which denies it and does not allow it to further go to your private subnets. An Egress only internet gateway is a similar VPC component. However, it is not created within a public subnet. An Egress only internet gateway itself is a component available for the entire VPC. Now let's go over some important exam points about NAT gateway and Egress only internet gateway. A NAT gateway, as mentioned, is added to a public subnet, which is a subnet with a route to an internet gateway. Now you associate an elastic IP address to the NAT gateway. This is important because when the internet needs to connect to your NAT gateway, it only knows the elastic IP address. The NAT gateway, when it receives the internet traffic via the elastic IP address, it translates the addresses back to the original source IPv4 addresses and routes them to your private subnet. This is useful and important from a security standpoint, because by associating elastic IP address to the NAT gateway, the internet only knows the elastic IP address, and the NAT gateway takes care of the actual network address translation and redirects them to the original source IPv4 addresses. Over years, NAT gateway can be used for both IPv4 and IPv6. However, NAT gateway is suited for IPv4 addresses when you want to restrict connectivity to your IPv4 addresses from the internet. An egress-only internet gateway is suited for IPv6 addresses only. An egress-only internet gateway is available to all subnets in the VPC. It is not created specifically in a public subnet. For egress-only internet gateway to work, you must create a custom route table, add a route that sends traffic to the egress-only gateway, and then associate the route table with the subnet. An important exam point to note is a NAT gateway should be added to each availability zone if you want it to be highly available VPC component across availability zones. This is important to note because NAT gateway is not automatically available for all availability zones. This brings us to the end of this video tutorial. In the next video, we will go over the other VPC components that help connect your subnets to your on-premises network, which are your site-to-site VPN and Direct Connect service. We hope you found this video useful, and if you did, please like and subscribe to our videos. Thanks for watching. Best of luck.